We are recording and I'm sharing my screen with my image mate. So the first thing we're going to zoom in on is, is number 6. Which powers are listed in order from least value to greatest value? Okay, cool. So I'm going to slide this to the side. Actually, I'll just write directly on this one. Before I do anything, I'm just going to look at my options. When I get problems like this, sometimes there's different values, but if you look carefully, it's actually the same 4 values, just in different orders. So I only have to figure out once what each one of these is valued, and then I'm going to put it from least to greatest. Awesome sauce. I'm going to close that real fast. So 1/4 to the 0 power. We learned earlier on last week that anything to the 0 power is always 1. So any non-zero integer. Okay, great. Or non-integer is the non-integer. Now this is 8.8 to the first power. So 8.8 to the first power is just 8.8. All right, solid. Now -5 squared. -5 times -5 is 25, because a negative times a negative is a positive. All right, so far this does look like it's in order. 8.1, or 8.8, I'm sorry, and then 25. And then that last one is, let's go purple, -1 cubed, which is -1 times -1 times -1. Well, 1 times 1 is 1. A negative times a negative is a positive. But then I have this third -1. -1 times a positive 1 is -1. So that equals -1. Now 1, 8.8, and 25, and -1, that's not in the right order. So the lowest order is this one here. So that's going to be number 1. And then the next number in order would be this one here, number 2. And then we have 8.8, which would be the third greatest value, and then the 4th greatest value. So I'm looking for A, B, C, or D, which is -1/3, followed by the 0 power, or this is the only one, actually right here. It's the only one that starts with -1/3. So that correct answer would be C. Questions on kind of my process? And is my handwriting too sloppy for you to even make sense of it?
No, it's fine.
Okay, fine, solid. Sweet. Okay, the next one we're going to look at is number 13. And this is, yes, I know I screwed up and I'm not going to count it, but I did want to talk about PEMDAS.
Lily, what is wrong with your microphone?
I don't think her mic's working, so that's probably what's wrong. So if you don't have a question, please just mute yourself. And if you do have a question, if you raise your hand, it will pop up on my little screen that you raised your hand. Okay, so we talked about PEMDAS briefly. Parentheses. Lily has a raised hand. Okay, so Lily, can you write in the chat box what your question is? Because your mic isn't working super great. And I'm going to go to the chat so that I can answer. Okay, so hun, just if you're ever late to a Zoom meeting, that's fine, no guilt. Just you get a piece of paper and catch on. We're going over the quiz that we took last week. That's what we're doing. Cool. All right, so PEMDAS. Please excuse my dear Aunt Sally, or parentheses, exponents, multiplication, division, distance, subtraction. So if we're looking at this, that's a lot of math that we have to figure out, right? I'm basically asking you to do all of this, you know, maybe 3 times, maybe 4 times, so you can find which is going to be the value 39. You're welcome. I know you love this.
Miss Kirby?
Yes.
Sorry, but when I did that question, and I did all 4 of them like twice, and I didn't get 39 on any of them, and I had to look it up, and I saw which one was 39, but I still didn't get how they got it.
Okay, great. Well, I'm really glad you're asking. Hopefully I can answer that question right now.
Okay.
All right, so this is the order of operations. Order of operations. So, which means, what do I do first? I do parentheses, then exponents, then I do multiplication, division, and then addition and subtraction. The reason these are the same color is because they're in the same family. So like you can just go left to right. Like you don't have to necessarily do this one before that one. And the same thing with addition and subtraction. Because subtraction is just adding of a negative number. And division is just multiplication of a fraction. Hey Lily, I do need you to mute your mic and then you can just chat with me in the group chat. Thanks, hon. All right, so I've color coded some stuff. So there's no parentheses here, but there is an exponent and there's multiplication and division. So those colors I'm going to use to kind of guide us through. The first thing I get to do is my exponent. So 4 squared is 16. And the best way to ensure that you get the right answer is to rewrite this sucker each time. And I can solve this. 24 times 2 is going to be 48. Okay, now I have some new things to do. So now I have to do this division problem. And then I can do this addition and subtraction problem, but I can't do anything here yet. So I can take 16 divided by 8, which is 2, minus 6. This is going to be 48 minus 8, which is 40. And it's going to be a positive 2. The sign here is going to follow the sign of this operation. So for some reason this was negative, then this would change. 40 plus 2 minus 6. So 40 plus 2 is 42 minus 6. Minus 6 would be 36. Right? Yeah. That is not 39, which is what I'm trying to figure out. Okay? That's example 1. So I did all that math to figure out the answer is not A. And welcome to the rest of your mathematical career. So the answer is not A. Any questions on this particular step? Okay, we're gonna do this 2 more times. So B gives us a different set of operations. It looks pretty similar, but it does give us this exponent here. So 4 squared is still 16. And then I am going to rewrite this entire thing so that I don't make a mistake. Too often people, me, myself included, mathematicians, we get a little sloppy. We do half of it in our head. And until you get this practice down, I'm sure some of you eventually will be able to do all this in your head. Right now, though, writing it down is going to very, very much help you. And I want you to be successful. So I see some multiplication and division, and I have to solve those first. So 24 times 2, that's 48, minus 8, plus 16 divided by 8 is 2, minus 6. And see how it's addition and subtraction all mixed together? You can just solve this left to right because it doesn't matter. 48 minus 8 is 40, plus a negative 4, right? Because 2 minus 6. You could also write that 40 minus 4, which is 36, which is not equal to 39. So this, my answer is not B either. Oh, sorry. Lily, yes. Were you going to type your question, Lily? Yeah, okay, so she's typing to me. Okay, so on the quiz, okay, Leah, you can ask your question. Wait, Okay, so Lily, we could talk about that later. Okay, because right now, if you have a question about this math, I'll take questions about this math that we're doing right now. So Leah, is your question about this math?
No.
Okay, so you can write it in the chat so that I don't forget and you don't forget, and then I'll address it when I'm done. Is that cool?
Yes.
You're amazing. Thank you. All right. Okay, last one. So again, please excuse my dear Aunt Sally, PEMDAS, that's our name of the game. We've got our first set of parentheses here. See these? All right, now inside the parentheses, we have an exponent. This is how we navigate that. Inside the exponent, we have to do all this stuff first before we can do any of the other stuff. Inside this exponent, it's 8 plus 4 to the second power. Now, according to PEMDAS, do I do addition before I do exponents? No. I have to do the exponent first. So I'm gonna start my problem. 8 plus 4 squared. So this is gonna be 8 plus 16, which is 4 times 4. And then I'm gonna rewrite my entire problem. I can't do 8 minus 6 yet because there's a division problem here. This division operation has to come before I do this subtraction. All right, so I know I probably could have multiplied that already, but that's okay. So I have to multiply. I also have to add this sucker in here. I gotta do that. Okay, so 8 plus 16. That's 24. Because I've now completed all the operations, I can drop the parentheses. Now, right outside the parentheses is this negative, this minus. That's gonna follow. I know 8 plus 16 is a positive 24. I know that. But because this minus is on the outside, I have to apply it. If by chance, you ready, Ginger, for this? If this was a negative 2 and there was a negative outside, that negative and negative would have made it a positive. So this subtraction sign is going to follow me down. I'm going to rewrite. Oh, I should have done that operation. Oh, well, that's okay. Divided by 8 minus 6. Notice there is no equal sign. These aren't equations. These are expressions. So I've got a multiplication problem here. I've got a division problem here. So I'm going to read this carefully. It's 24 times 2 and negative 24 divided by 8. That's how I'm reading that. So 24 times 2 is still 48. Negative 24 divided by 8. Oh, we got questions. So Lily, what's your question? So Lily, just start typing your question, okay? Thank you for raising your hand. So type your question and then raise your hand, then I can keep going. Okay, great. Thank you, hon. The work I'm doing, you can't see the screen? I can reload it, sure.
I mean, I could see it.
Okay, that's okay. So I'll just give it a go. And I'm gonna share my screen again. So hopefully that worked. And I'm gonna move this somewhere. Yay, I'm so glad it worked. Good, good, good. Happy, happy, happy. Happy days, happy days. Okay, let's put that somewhere. Okay, so I have 24 times 2, which is my 48. Negative 24 divided by 8, which is a negative 3, minus 6. Now this is just addition and subtraction, right? 48 minus 3 is going to be 45 minus 6. 45 minus 6 is 30. is 39, which is the answer I was looking for. 39 does equal 39, which was why the answer was D. Okay, that is a bunch of cool math. It worked. So I understand that I'm not actually counting this problem anymore because I screwed up in my on my end. So sorry about that, guys. But hopefully this cleared it up. Doing the exponent within the parentheses. All right, net crack. Oh, so the reason I did give you a piece of paper and a pencil, or ask you, I didn't give it to you, ask you to get a piece of paper and pencil, is so that you can write these things down, so that you can even write notes down. And if I'm going too fast, you can always go through this again on the Google Classroom, or just say, Mrs. Kirby, can you slow down? Because I'm very happy to do that, to just slow down. The answer was 39. Yay. Cool, coolio. All right, so I'm moving on to, we have 3 on this page. We're gonna do 14, 20, and 23 together.
Miss Kirby,
Yes.
on the second page of the test, how come it only went to 23 and it didn't go to 26?
No idea. Great question. You're the first person to tell me that. It should have gone to 26. I don't know. I'm sorry. I'm
Okay.
gonna write myself a note on that. You feel cheated? You're like, I should have done that. Quiz 26. I'm writing myself a note. Thank you. I really appreciate all of your input and your feedback. And if something doesn't work, tell me. If it is working, say, keep doing this kind of thing because that helps me learn. And if I'm giving you something that's not helping you learn, tell me that too, so that I can make this great for all of us. Okay, so 14 says, which power has a greater value? And just so you know, the reason I picked these questions is because these are the ones that were the most frequently missed. That's why we chose these questions. If there's a question that I don't plan to go over that you want to see me model, you can ask me to do that. Oh, Grace, 23 was the answer spot for 26. Oh, interesting. Okay. I'm sorry for that. That was an error on my fault. All right, so which power has the greater value? So if a number has a greater value, that means it's bigger. It's larger, it's farther along on the right on that number line. So if we have -3 squared, let's see if I can do this well. That's -3 times -3, which is a +9. Cool. All right, now -2 cubed. That means I'm going to take -2 3 times. And I do believe that writing it out in this logical pattern supports your comprehension, and it's going to help you get the right answer, particularly when you were dealing with negatives and positives. So -2 times -2 is a +4, times another -2 is a -8. So when I map that on a number line, which is greater? Which is greater? So I can look at this exponent and think, oh, well, yeah, that's going to be bigger, but it's actually not. So thinking about how negative numbers behave when they're multiplied by each other is muy importante, is very important. Any questions on number 14? Cool. Okay. The next one we're going to look at is number 20. Okay, 20 was tricky. That was my note to myself. Complete the following statement. Let's see if I can stick on the way. It says, as the value of n, which in this case here is my exponent, okay? So when that number gets bigger, what happens to the value of this particular expression? So I'm not trying to confuse you, except for I know that this is confusing. So This number is tricky. So if this number is 2, if n is 2, what happens? If n is 3, what happens? If n is 5, what happens? So it's asking, as my exponent increases for this particular non-integer number, 1/4, what happens to the value? And I said, does the value increase or decrease? Okay, so I took a few notes just to remind us of some things. Integers are non-fraction numbers. And of course, now I can't see my notes anywhere. Good job, Mrs. Kirby. Oh, there they are. Okay. All right. Oop. Hello, hello everyone. So excited you're here. Integers are positive and negative non-fraction numbers, like 5. 5 squared is 25. 5 cubed would be bigger than that, like 125. And the larger this number gets, n, the bigger the value is. So this integer increases in value as n increases, as the exponent increases. However, this is not an integer. Non-integer numbers, they fit between integers, like -1/2 and 1 1/3. And so they behave a little differently. These ones have a pattern that we can count on. If you have a mixed number, it's still going to increase if you have a whole. But if you don't have a whole, if you only have a fraction or a partial like this, watch what happens. 1/2 to the n, I'm just giving an example. So 1/2 squared is 1/4. Well, 1/4 is not bigger than 1/2. So when, and let's say I do 1/2 cubed. Well, that's going to be 1/2 times 1/2 times 1/2. 2 times 2 times 2 is 8. Well, that's 1/8. That's even smaller. So when these non-integers, when these fractions and decimals are affected by exponents, when they're taken to a power, they actually decrease in value. So that's something that we can count on for fractions and for decimals. So let's say you have 0.0125 squared. And this is my answer. That's a lot smaller than this. But if I take a mixed number, 5 1/4 squared, it's going to be 27 and 286 over 625. So this still got bigger. It's kind of wonky, but it still did increase. And that's because it had this, what's called a coefficient. If it has that whole number part. So I went through your book just to check, and that particular question was just a pattern recognition. So a little tricky, sorry about that. Questions on integers versus non-integers and how they play with exponents. Feeling good? Feel a little bit better? Gavin Boyd, go for it.
So it's not a question about the integers, but on the test, it skipped 23, 24, and 25, and went straight to 26.
Okay. So the 23 on the multiple choice was number 26?
Yeah. And there was no 24, 25, or 26
Got it.
for answers.
Okay. And for the answer key?
Yeah.
Okay. Thank you. All right. So it looks like, no, okay. All right, that's fine, Dominic. I really appreciate your feedback. Again, this is new for me, and I will do better next time for the next quiz. I would never hurt your grade for something that I made a mistake on. So if any of you are willing to even like, if you're my first quiz takers, I mean, Bryce was, I think, one of the first people to take the quiz, and he's like, hey lady, he was so nice about it though. I fixed things actually even before most of you took it, because someone took it early and was able to give me some feedback. So thank you. I am not perfect, and I really, really appreciate your support through this, and I will try to be better. All right, so I have one more that I want to show you, and it is number 16 or 23, which maybe I screwed up, which is why at least the test told me you got it wrong, maybe you didn't. But write 16 as a power two different ways. So we have to think about what's the prime factorization of 16? So 16, okay, there we go, 16. We have 2 times 8, okay, but this can keep going. This 8 can be, the factors of 8 are 2 and 4, and then the factors of 4 are 2 and 2. So the prime factorization of 16 is 1, 2, 3, 4, 2 times 2 times 2 times 2. Okay, so that's 16 that's the prime factorization, and that's actually what we're going to be working on a lot this week, is making these kind of trees, these factor trees. So I could write 16 as 4 times 2 squared. I could also write it as 4 squared. I could also write it as 1, 2, 3, 4, 2 to the 4th power. 1, 2, 3. I could do 2 to the 3rd power times 2, which is kind of stupid because that's the same base. But these are the kind of 2 we were looking for. But if there were other choices, can I get a factor tree plant? Charlie, you are so funny. Yes, Charlie, go get us a factor tree plant. Some of us might be able to just see that. I like to draw my trees. I like trees. So 1, 2, 3, 4. So either of these work. The 4 to the 2nd power or the 2 to the 4th power. That's different ways to write 16 as a power in 2 different ways. Okay, any questions on this particular question? We're gonna be really, really excited for Madi to be talking about trees, even though it's just factor trees. I'm going to stop sharing for a moment, and I'm going to pause. Great. So 9.2, prime factorization, is our topic for this week. We're actually going to do 9.2 and 9.3 because I think just doing one lesson a week is too slow, and we're not going to be as prepared for 7th grade as we possibly could be. Also, I wanted to do a quick announcement. This is not the perfect time for it, but if you are planning on taking advanced math next year, I'm going to repeat that one more time. If you are planning on being in accelerated 7th grade, you got to email me that. So I am going to be giving the principal a list of students who I believe are ready for accelerated 7th grade. And those are students who are going to take IM1 as 8th graders, right? That high school math class, excuse me, high school level math in 8th grade, because you're not allowed to take IM1 in 8th grade if you don't take accelerated 7th grade math. So I have my own list of students who, through their performance and through their effort and through their test scores, I know are going to be prepared for accelerated 7th grade. If you don't want to be in accelerated 7th grade, you can email me that too. So you can, oh, go ahead, Bryce.
What if we're already on that list, do we need to email you or?
Well, I wasn't going to put on blast who's on the list, but Bryce, you're good. Okay. And anyway, so
Thanks,
in
Kirby.
general, because the thing is, just because you could do accelerated 7th grade math doesn't mean you want to. And so, you know what? Why don't I email you? I'm going to email you, everybody, and I'll ask you a question. Okay. And how you answer me is going to help me make my little list. Cool. It's going to be a Google form. You're just going to click yes, no, maybe. Let me talk to my parents. If your parents want you in accelerated 7th grade math, that overrides you. So we have a list of parents who have said, like, we want our kid in honors. We want our kid, you know, doing this. And so that.
Miss Kirby,
Yes.
are we allowed to email you and ask you if we're on the list?
Sure. You can always email me anything. But just save your typing though, because I'm going to send you all a Google form. Yes, Lily, what's up? So Lizzie, great question. She's asking, does that mean honors? So for math from here on out, they don't really call it honors. They either call it accelerated or just regular. So 7th grade math is 7th grade math. Or if you're in accelerated 7th grade math, that means you're going to go through all of the 7th grade curriculum and the 8th grade curriculum so that you can take IM1, which is 9th grade math, in 8th grade with Miss Takamoto or with Mr. Randall. Okay, so so my list is literally just in my head. I do not have it written down yet, and I was just asked to make this list yesterday. So the Google form is going to say, it's just going to ask, are you interested in being an accelerated 7th? Yes or no, right? And if you want to be, if you want that experience of being in advanced math, it's available to you. And if you want to be in accelerated math and I have concerns, then you and I can chat about that. Is that fair? So, all right. This is definitely not something I want you to worry about, because if you want to be in that class so darn bad, we'll make that work. But if you know you're not, that you don't want to be, then that helps me out. And I want you in the right place so that you're successful, right? Wherever that is. Because it is a lot of work. It's work. Being in honors is more work than not being in honors. And being in accelerated math is more work than not being in accelerated. That's why it's an option. So if you guys don't mind, I'm gonna stop that part of the conversation, which I realized I probably should have made an entire Zoom meeting about, considering you guys are so passionate about your education and I'm really proud of you. Okay, so Charlie, okay, so all right, right now in the Zoom chat is not the time to tell me what you want. Right now you're gonna get your paper and we are going to look at some super fun stickers, which for some reason makes life more exciting for me. You know what? Bryce too. You should see Bryce's room. So many stickers everywhere. Isn't that right, Bryce?
Pictures of cars, yes. Not stickers.
Okay. So finding factors is not new for us. We have done this before. So whole numbers that are multiplied to find a product are called factors. So whole numbers, muy importante. Now, Anna wants to build a rectangular garden with an area of 24 square feet. What are the possible ways? So for 24, I have to figure out what are all of those factors. There's different ways she could draw this to make this garden. She could make it 2 by 12, right? 2 feet by 12 feet. So it's this crazy column. She could make it 3 by 8, still very rectangular, or 4 by 6, which is a lot more like a square. So these are the different factor combinations for that particular integer. Okay, so all of those are different ways of finding 24. So this is another diagram that you can use. And this is often how I write mine, right? Just that list of factors. And that's pretty familiar with how we've done it in the past. So the factor tree is going to be something that you're going to practice this week. But just to refresh, I'm just going to do this first one. So 21. So factors of 21 are 1. 1 times 21, right? And then we have 3 times 7, and then that's it. If you want to put them in numerical order, you can, but that works for me. Cool? Awesome sauce. Any questions on finding factors of numbers? All right, let's get the big bucks. So using that ladder diagram that I was kind of using before. So the ladder diagram can be used to find the prime factorization. Now these numbers here are going to be the ones that I box in their simplest form. So sorry, what am I doing? Okay, so write 132 at the top, and that's divisible by 2, okay? We got that part? Yes? No? Maybe? A little bit? So the boxes are where we put the prime factorization. This can't be simplified anymore. So 2 times 66 is 133. Now 66 can be reduced further. 66 can be reduced to 3 times 33. Oh, sorry. Yeah. That's not right. Typo, sorry. Is that 2 times 33? And then 33 can be reduced into the 11s, okay? And then 11, we can't reduce that further. So the prime factors are 2, 2, 3, and 11. And they can be written on the left side of that step ladder. So I prefer the tree, but that's just me. So if you like the ladder, great, you can use the ladder. So 54. Starting with 2 is brilliant because it's an even number and it's prime. So 2 times 27 is 54. Well, 27 isn't prime. That can be simplified into 3 times 9. 3 is prime, love it. I'm gonna circle that sucker. 9 is not prime. 9 can be simplified into 3 times 3, and obviously 1 is always there. So 54 is 2 times 3 times 3 times 3 times 1. Last one. If one person uses a ladder diagram and another uses a factor tree to write a prime factorization, will they get the same result? Yes. There's only one unique prime factorization for every integer greater than 1. There's only one way to do this. One list of prime factorizations. Okay, I'm seeing some questions. I am going to money, math, paying attention. Okay, you guys are very silly. All right, I'm gonna, okay. So this week's practice is gonna be a lot of word problems. You're welcome. You're super, super, super welcome. Let's just look at 10, just for giggles. Brandon has 32 stamps. He wants to display them. Okay, stamps. I'm imagining these are postage stamps. This is someone. He wants to put them into rows. Now, with the same number of stamps in each row, how many different ways can he display his stamps? Okay, so we take 32 and we can find our factors. 2 times 16, and then 4 times 4, and 2 times 2. So we have 2, 2, 2, 2, 2, 2, 2, 2, 2. Is that right? 1, 2, 3, 4, 5. Great. So how can I use that information to help me figure out how many rows? Okay, so Lily has a question. I'm gonna go to the chat real fast. Well, you try to either draw or mathematically figure out best way to do that. Hi, Parker. Okay. Okay, so Lily, okay, what's your question? So is your question just about the number 1 in general? Okay. All right, you figure out what your question is, and I'm gonna brainstorm this. So there's 6 different ways. We could do 1 row. Let me find another piece of paper. Piece of paper. Oh, I found a piece of paper. Here it is. Har, 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 har. So we could do, so if my number's 32, and what does he say? He wants to display the same number of stamps in each row. He doesn't say it has to be a square, but same number of stamps in each row. So he doesn't want some like wonky presentation with like 1 extra. So he could do 1 row of 32. He could do 2 rows of 16. See how I'm doing that there? He could do 3 rows. He could do 4 rows of 8, right? And all I did was take, so here's 3 rows, so there's 8, and then 4. So taking 2 to that 5th power, 2, 2, 2, 2. What are my options? Did I miss any? 2, 4, 6, 1, 2, 3. No, that looks about right. No, what did I say? There's 6 choices. So we've got 3. What are our other 3? 4 rows of 8, 2 rows of 16, 1 row of 32. We could have 8 rows of 4. Oh, okay. Rows, columns, right? Okay, so Lily, there's 2.2 homework and none of 2.3. I will check on that. There should be a 2.3 homework, so thank you for pointing that out. 9.3 homework. Okay, so I did know that there was a double of a homework assignment. Grace pointed that out, so I think I deleted that extra one. So hopefully nobody, don't do 2 9.2 homeworks. Okay, so none of okay, so Lily, do what's posted, but I will double check to make sure. And if there is a 9.3 that I assigned, but it's not showing, I'll make sure the due date isn't until Tuesday, so you guys have more time. Okay, so here's the fun part. You guys ready? We're almost done. Almost done. So if I have 1 row of 32, I can also have 32 rows of 1. If I have 2 rows of 16 stamps, I can also have 16 rows of 2 stamps. If I have 4 rows of 8 stamps, right, then I can have 8 rows of 4. So that's where I get my 6. Do you notice a pattern?
Miss Kirby,
Yeah, what's up, girl?
we can't see what you're writing.
Dang it. This whole time, have you not been able to see what I'm writing?
Yeah, the paper's too high up.
I can see what you're doing.
Okay. Sorry. Thank you. Okay, now do you see the pattern? 1 to 32 and 32 to 1. Those are different options. But I just switched them. So that is number 10. So if you have that one in your online book, then that should be helpful. Yay, helpful. All right, so module 9, I think I don't, okay. Leah, thank you for your question. Can I email you?
Yes.
Cool, okay. So I am gonna stop my screen sharing. Stop.